Example 1. All right, I've got the mean of a sample of 25 observations is 6.4, and then I've got the mean of a second sample of 30 observations is 7.2. Calculate the mean of all 55 observations. So the first sample, which I'll do in green, 25 observations, and the mean is 6.4. So I can work out the total of the first sample, 6.4 times 25, 160. Now the second sample, which I'll do in blue, has 30 observations, and the mean is 7.2. So I can work out the total there. 7.2 times 30 gives me a total of 216. So I can work out the total of all the 55 observations, 160 plus 216. And I can work out, therefore, the mean of all 55 by doing the total, 376, divided by the number of observations, 55. Gives me an answer of 6.84 to 2 decimal places. Example 2. Right, Rebecca records the shirt collar size, which we're calling X, of all the male students in her year, and here are the results. Well, straight away I can work out the number of students who she surveyed, but I'm not sure that's going to be needed for A. A says find the mode. Well, the mode is the most common shirt size, and I can see that that is 16.5, because there were more people who had a shirt size of 16.5 than any other size. Now, the median. Let's find out how many people she surveyed for the median. So I'm going to add up the frequencies here. So I've got 20, what do those add up to? 95. So n is 95. Okay, so the median is going to be, well, the 95 divided by 2 would give me 47.5. So the median is going to be the 48th reading. Right, so which one's the 48th? Well, let's have a look. There are 20 there, and then another 29. So that's 49 up to 16, aren't there? So the 48th would be 16. So the 48th shirt collar size is 16. Okay, part C. Right, the mean. I'm just going to delete what I've done here so I can keep the question on the screen. Right. Now the mean shirt size is going to be the total of all the shirt sizes divided by the number of shirt sizes. So I've got 3 people who have size 15, 17 people who have size 5.5, 29 people who have size 16, 34 people who have size 16.5, and I've got 12 people who have size 17. So that's the total of all of the, how many collar sizes is that? All of the 95 collar sizes. So if I put that into my calculator, I get a total of 1537.5, which then I divide by 95 to find a mean size of 16.2. Right, part D. Explain why a shirt manufacturer might want to use the mode when planning production numbers. Well, the mode is an actual shirt size, isn't it? Whereas 16.2 is not an actual shirt size. Example 4, right, data from the large data set. Now we've got the daily maximum gust in knots during the first 20 days. So N is 20. Okay, and I see that helpfully the data is put in numerical order. Look, from the lowest 14 all the way up to the highest 39. Okay, find the median in the interquartile ranges. Right, let's find the median first. Now we've got 20 pieces of data. So we're going to want to look at the 10.5th value, the one in between the 10th value and the 11th value. So the one in between 22 and 23. So that is going to be 22.5 knots. Right, now let's have a look at the quartiles. quartiles. So we're going to need to find the first quartile, the lower quartile, Q1. Now Q1 is going to be halfway through the first half of the data. So it's going to be halfway between the 5th and the 6th. Well, the 5.5 value is the one that is halfway between 18 and 18. Well, clearly that is 18 knots. And now let's have a look at Q3. Q3 is going to be the one in between these two, the 15th and a half data value. So that's the one that's halfway between 25 and 26, so 25.5 knots. So that is the median and the quartiles. Example 5. The length of time to the nearest minute, that's going to be important, spent on the internet each evening by a group of students is shown in the table. Part A, find an estimate for the upper quartile. So in part A, I'm trying to find an estimate for Q3. Now, how many people are there altogether? Well, there are 70 people represented on the table. So which data value am I going to look for Q3? Answer, find 3/4 of 70. So I'm going to be looking for the 52.5 data value. I'm going to be looking for the length of time spent on the internet by the 52.5 person of these 70. Right, well, here are the first 2 people. And there are the first 27 people. Right, I've got 57 people up to here. So clearly the 52.5 person is going to be in this class here and is going to be one of those 30 people. I've just got to work out which one of those 30 people. Well, definitely the length of time spent is going to be more than the beginning of that class. But what is the beginning of that class? You need to be very careful here because these times are given to the nearest minute. The class doesn't start at 34 minutes, it starts at 33.5. And it doesn't end at 36 minutes, it ends at 36.5 minutes. Okay, so this class width here is actually 3 minutes, not 2. Right. So how much time does the 52.5 person spend online? Well, they're about here, aren't they? So they definitely spend 33.5 minutes. And then if we assume those 30 people are evenly spread across that 3 minutes, then we're going to have some proportion of that 3 minute spread to add on to the 33.5 minutes. What proportion of that 3 minute spread? Well, we've got 27 of the people already accounted for up to here, and we want to make our way up to 52.5. So 27 to 52.5, that's going to be another 25.5 people. So the proportion of the 3, the class width I want to add on, is 25.5 over 30. So that expression there gives me the length of time spent on the internet by the 52.5 person, which works out to be 36.05 minutes. Okay, now what about P10, the 10th centile? Let's have a look. Well, the 10th centile is going to be the 7th data value because there are 70 people in all. Now, where is that 7th data value going to be? Right, let's zoom up this table. Well, it's not going to be in this class. It's going to be in this blue class here. It's going to be one of those 25, isn't it? The 7th person. Now, where does that class begin and end? Well, it begins at 31.5 and it ends at 33.5. So tricky. This class is only 2 minutes wide. And how far into that class am I going to want to go? Well, I want the 7th person, so I need to go 5 people into this class. So what fraction into that class do I want to go? 5/25, a fifth of the way through that 2-minute range. And at the beginning of that class, of course, I've got 31.5 minutes. So there is an expression for the 7th data value. If I work that through, I get 31.9. And that is example 5. Example 6. The table shows the masses in tons of 120 African bush elephants. So I know that my N is 120. Find estimates for the range. Right, well, the range is going to be the weight of the heaviest elephant, subtract the weight of the lightest elephant. I'm going to have to assume that of these 19, one of them is 6.5. And I'm going to have to assume that of those 13, one of them is 4. So that gives me a range of 2.5 tons. So that's question A done. Right, question B. The interquartile range, right. So I'm going to need to find the value of Q1, and I'm going to need to find the value of Q3, and then I'll find the difference between those. Now, there are 120 elephants, so Q1, 120 divided by 4, we're looking for the 30th data value. So let's have a look. Now, the 30th data value is not going to be between 4 and 4.5, but it is going to be between 4.5 and 5. So the 30th data value is going to be 4.5 plus, now what fraction of that way will I have to travel? I've done 13 and I want to go up to 30. So I need 17 more out of those 23 multiplied by the class width, which is 0.5. So that gives me a value there on my calculator of 4.87 tons. So that is my estimate for the weight of the 30th elephant. Q3, 3/4 of 120 is 90. So I need the 90th data value. Right, let's have a look. Where's the 90th going to be? 13, 36, 67. The 90th is going to be somewhere in this lot. So the 90th data value is going to be 5.5 plus. Now, how far into that lot do I need to go? Let me just check my maths here. So that was 36. So that is 67. So I've got to 67 here, and I want to go up to 90. 90 minus 67, I need another 23 of those 34. So 23 out of 34 times the class width, which is a half. So if I work that through on my calculator, I get the answer of 5.84 tons for the weight of my 90th elephant. So the interquartile range is going to be 5.84 minus 4.87, which gives me an answer of 0.97 tons. That is the difference between the weight of elephant number 30 and the weight of elephant number 90. Right. Okay, part C. I need the range of the 10th to the 90th into percentile range. Right. I'm just going to delete what I've done so that I can still see the table. Right, part C. Okay. Now, given that there were, I've forgotten how many elephants there were now. Right, given that there are 120 elephants, then the 10th centile, P10, is going to be the 12th elephant, and the 90th centile, P90, is going to be 0.9 times 120, the 108th elephant. Okay. Now the 12th elephant is going to be in this first class here. So its weight is going to be 4 plus 12/13ths of 0.5 because it's almost going to be at the end of that class. So that's going to be the weight of the 12th data value, which is 4.46 tons. Now the 108th elephant, let's have a look at that. So, well, if I've got 120 in all, and I've got 19 in the last one, clearly the 108th is going to be in the last class here. Now, how many elephants have I got up to there? 101. So the 108th elephant is going to definitely weigh 6 tons. And then it's going to be a fraction of the way through these 19. It's going to be 7 more elephants of the way through that 19 multiplied by the class width gives me a value for the 90th elephant of 6.18 tonnes. So the interpercentile range, P90 minus P10, will be 6.18 minus 4.46, giving me 1.72 tonnes. And that is example 6 finished. Example 7. Right, the marks gained in a test by 7 randomly selected students are as follows. Find the variance and the standard deviation. Okay, well, let's start off by finding the variance. Now I know that the variance is the mean of the squares, subtract the square of the mean. So the mean of the squares, subtract the square of the mean. So what I'm going to do is I'm going to find the mean of the squares, 3 squared plus 4 squared plus 6 squared plus 2 squared plus 8 squared plus 8 squared plus 5 squared, and I'm going to divide that by 7, the total of the squares divided by 7 to give me the mean, and from that I'm going to subtract the mean of the data. The mean of the data is the sum of the data, 7, 13, 15, 15, 23, 31, 36, divided by the number of pieces of data, and I'm going to subtract the square of that, of course. So that gives me 218 over 7 minus 36 over 7 squared gives me a variance of 4.69. Okay, and the standard deviation, of course, is simply the square root of the variance, 2.17. And that is example 7 done. Example 8. Right, Shamsa records the time spent out of school during lunch hour to the nearest minute. I wonder if that'll be important. Of the female students in here, the results that are shown in the table. Calculate the standard deviation of the time spent out of school. Right, well, first of all, I wonder how many students she asked. Let's add up those frequencies. And if we do that, we see she asked 83 students. Okay, well, to work out the standard deviation, I'm going to need to square root the variance. So let's start just by working out the variance. So the variance is going to be the total of the squares divided by 83, the sum of the mean of the squares. And from that, I'm going to subtract the square of the mean. That's right, the square of the mean. There it is. So I need to work out the total of all the squares. So that's going to be 3 times 35 squared plus 17 times 36 squared plus 29 times 37 squared plus 34 times 38 squared. And I'm going to divide that by 83. And from that, I'm going to subtract the square of the mean. So the square of the mean is going to be the total time spent out of school, 3 times 35 plus 17 times 36 plus 29 times 37 plus 34 times 38. That's the total time spent out of school, divided by 83 to find the mean time spent out of school. And of course, I'm going to square that. Okay, so a bit of calculator action, and I get 114,504 over 83 minus 3082, which is the total of all the times, divided by 83 to give me the mean of all the times squared. And that gives me a variance of 0.74147, and so on. So my standard deviation is the square root of that, which is going to be, on my calculator, 0.861. That'll do. Put that to 3 significant figures. Okay, that is example 8. Example 9. Andy recorded the length in minutes of each telephone call he made for a month. The data is summarised in the table below. calculate an estimate of the standard deviation. Right, okay. Well, I'm going to need to use the midpoints here, aren't I? Because, of course, I've got group data. So I'm going to take the midpoint of each of these classes. That's going to be the important value for us to work with. Oh, that's not 22.5. That's got a class width of 40. So halfway between 20 and 60 is 40, and halfway between 60 and 70 is 65. There we go. Okay. Right. So we're going to need to start with, well, let's start with the mean of the squares. Right, how many phone calls has he actually made? Let's have a look. He's made 27 phone calls in all. Now I'm going to need to add up the total of all the squares. So there'd be 4 2.5 squares. There'd be 15 7.5 squares. There'd be 5 12.5 squares. There'd be 2 17.5 squares. There'd be no 40 squares, and there'd be 1 65 squared. And I'm going to need to divide that by 27. All right. So that, which by the way is 6487.5 over 27, is the mean of the squares. So from that, I'm going to need to subtract away the square of the mean. So we best work out the mean. Sum of fx over the sum of f. Okay, so I've got 4 2.5s, 15 7.5s, 5 12.5s, 2 17.5s, no 40s, and a 65. And I'm going to divide that by 27. That's the total of all the minutes spent on the phone, divided by the number of calls. So that gives me 285 over 27. So my variance is going to be 6487.5 over 27. Subtract the square of the mean, that squared, which on my calculator gives me 128.85802. So the variance is what I'm asked for. So I'm going to square root 128.85802 to give me an answer of 11.35 for the standard deviation of the length of the telephone calls. Example 10. Right, we're coding. Okay. So a scientist measures the temperature X degrees Celsius, 5 different points in a nuclear reactor. The results are given below. Use the coding to code the data. Right. Well, I'm going to be very clear about what are my X values and what are my coded values Y. So I'm going to write X here. I'm going to write 332, 355, 306, 317, 340. And now I'm going to code that data using this formula here. So I'm going to do that in green, my values of Y. So each time I'm simply going to take away 300 and divide by 10. 3.2, 5.5, 0.6, 1.7, and 4. So there are my coded values Y, and I've used that formula. Part B, calculate the mean and the standard deviation of the coded data. Right, I'm going to stick with my green colour here because I'm working in Y. So the mean of Y will be the total of Y. What do they add up to? So I just add those up on my calculator. They add up to 15, and there are 5 data values in all. So the mean of Y is 3, of course. So that's good. Now I also need the standard deviation. I'm going to start by working out the variance. So the variance of Y is going to be the mean of the squares, isn't it? So I'm going to do 3.2 squared plus 5.5 squared plus 0.6 squared plus 1.7 squared plus 4 squared. And I'm going to divide that by 5 to find out the mean of the squares. And from that, I'm going to subtract the mean squared, well, the mean is 3. So I'm going to subtract 3 squared 9 from that. Right, on my calculator then, I get 59.74 over 5 minus 9, which gives me a variance of 2.948. So my standard deviation is the square root of 2.948, which gives me 1.72 to 3 significant figures. Right, so I have done part B, calculate the mean, the standard deviation, the coded data. So that's the mean of y and the standard deviation of y, just to make it clear. All right, sigma y there, sigma subscript y. Okay, use your answer to part B to calculate the mean and standard deviation of the original data. Right, so I'm going to move back to a blue pen now because I'm dealing in x's. Right, now if x bar will be 10 times y bar plus 300. All I've done is make x the subject of that equation there. So that means that the mean of x will be 10 times 3, the mean of y, plus 30. So the mean of x is 330. And what about the standard deviation of x? I'll write sigma subscript x to make it clear what I'm doing. Well, what's happened is each data value has got 10 times smaller, well, the spread has got 10 times smaller because I've divided each data value by 10. So my standard deviation of x compared to y will have to be 10 times larger. Gives me 17.2. That is example 10 done. Example 11. From the large data set, data on the maximum gust G, let's do G in blue, is recorded during May and June. The data was coded using H equals G minus 5 over 10. And the following statistics found. So I've got the summary statistic for H, and I've got the mean of H, and I know that N is 61. Okay, calculate the mean and the standard deviation of the maximum gusts. Right. So the formula is that H was coded, G was coded using that formula into H. So the mean of G is going to be 10 times the mean of H plus 5. And I know the mean of H is 2, so the mean of G is 25. Great. Okay. Now, I'm going to use, so I've calculated the mean of G. I need to calculate the standard deviation of G, but before I do that, I'm going to calculate the standard deviation of H. Let's start with the variance of H. Well, the variance of H will be the summary statistic divided by N, which is 61, of course. So that's the variance of H. So the standard deviation of H will simply be the square root of that. On my calculator, I get 0.845 and so on. So that's the standard deviation of H, but of course for H, the spread has been made 10 times smaller. So the spread of G, standard deviation of G, will be 10 times larger. So it will therefore be 8.45 knots. And that is example 11 done.